it says A plus 2B equals C plus D here. And we give it some trials and some concentrations and we're given some rates here. So let's see, I have A plus 2B yields C plus D. And then I want to solve for my K value here. So in order to solve this problem, again, I'm going to just simply verify the solution. So I can look here, write out the reaction, which is good. And what we can do is we can actually write out the rate equation. So R here equals K times, and then what we can do is we're multiplying simply the reactants here, which is simply just K times B here. And we can actually rewrite this as K times A, and B here is going to be squared because I have the I have 2 in the coefficient here as well. So I can actually write this as a 2. And I'm just looking at the solution here. And they are, what they're doing is they're substituting, again, one point versus another point and just using substitution. So let's do that. So let me write out the general equation first, and then we'll be able to solve for this using substitution. So this here, and they give it to us as M and N, but it really doesn't matter which kind of letters you use in this case. And what we're doing is we're simply just subbing in a point. So I believe they subbed in the first point. Yeah, they subbed in for the first, they subbed in the first point for equation 1. So this here is trial 1. So trial 1 says that the rate here is 0.0123 is going to equal K times A here, which is 0.260 to the power of M multiplied by 0.230 times the power of N here, which is kind of our first equation here. And then what they did was they actually calculated, they used the second equation here, and then they plugged in the exact same thing for the second equation. So I would get 0.0123 equals K times, this here is also 0.260 times M, and I have 0.460 as the power of N here. And what we can do is we can simply just calculate, our M and N values by simply looking at these two values here. So we can say here, what they're doing here is they're dividing both equations, simply just using substitution. Again, if rate equals rate here, then I can simply just equate these two equations together. And as you can see here, if they divided both equations together, they're going to get to the power of N equals 1. So this here is this here will equal 1, and M here is going to equal 2 for this problem as well. So what they're doing here is they're simply eliminating the M first to only solve for this N value. So you're going to get so again, this basically everything here crosses out. So again, it's because 0.0123 divided by 0.123 is simply just 1. K divided by K is 1, and these two guys here is also 1. So you can think of it as this is 1 equals 0.230 divided by 4.60 would be, you can think of this as 2 to the power of N here. So dividing equation 2 by 1. So sorry, this is actually flipped here. So let me redraw this here, because we want the bigger number on top, so it gives us a positive exponent. So we're basically just using the rate law, and we're comparing the rates of one versus the other, and we can simply just use substitution to solve for our K value, and that's what we're doing here. So 4.60 N is 0.230 N. If you divide 4.60 and 230, you can get 2 to the power of N. So N here is going to equal 0, right? Because anything to the power of 0 is going to equal 1. So N here is going to be the power of 0. We can do the exact same thing to solve for M value, right? So we basically just look at our points again, and we could look at our A values here. And what we can do is we can actually write another equation for trial 3 here, which is I have 0.520 is going to equal 0.230 sorry, 0.0492, sorry. 0.0492 is going to equal 0.52 k, sorry, times 0.520 to the power of m, and no n now, which is 0, right? So this is 0.230 to the power of n. And I can simply divide this by our first point here, so, or our second point here, which, or honestly any of these equations would work. So I'm going to write 0.260, or sorry, this is 0.0123 equal k times I have 0.260 and then this here is 0. For the sake of time, maybe I'll just divide it by 0.23 to get me a nice 1 value here. 230. And so this here is equation 3 divided by equation 1 here. So we're simply just taking these two rates and we're dividing them, right? So 0.0492 divided by 0.0123. This gives us a value of 4. The k's here cancel out. 0.52 divided by 0.260 is simply to the power of 2. The m stays here. And these two guys also cancel out. So m here is going to equal 2, and n here equals 0, right? So now what I can do is I can finally write my rate constant, right? I can say that the rate is equal to k times a here, which is to the power of m, which is 2, times b to the power of 0. So this here, again, anything to the power of 0 is going to be simply equal 1. So what I can do is I can actually simply just cross out b in our mathematically speaking, because anything to the power of 0 equals 1. So it's not dependent on the concentration of b here, which means the rate here is simply going to be k times a squared. And what we can do is we can actually sub in any of these points to figure out this problem here. So as you can see, what they did was they figured out, they plugged in this case here, they plugged in the first point to solve for our value here. So rate, again, is 0.0123 equals k times a here, which is 0.260 to the power of 2. And again, we don't really care about b here, because if I wrote b 0.230 to the power of 0, this here is going to give me simply just a 1. So I just care about these guys here. So I have 0.0123 times k, whatever 0.260 squared is going to give me 0.0676. And I can simply just divide both of these guys to figure out k, right? So k is simply 0.0123 divided by 0.0676, which would give us a value of 0.1819. And this here is going to be in molarities minus 2, second minus 2. And that's it should be positive 2 actually in this exponent here, because this guy here was squared. Oh no, it should be minus 2. Yeah, because I need to get molarity squared here. Or sorry, I need to get molarity to the power of molarities per second for rate. So let's see. I need to get this here would be a minus 1 as well. Minus 1. Yes, would give me that. So this here would be the correct solution. 1.8 times 10 to the -1, or 0.1819. So this here is the correct solution for this problem.